As for introduction, this is basically a 16-bit CPU data pad using 8 opcore. The objective for this project, mini project, was to design a 16-bit CPU, an ALU, and implement 8 operation codes, develop opcode-based control, and implement zero flag and carry flag. For design specification, this is a 16-bit input, which is A and B, and also there are 16-bit output, and we use 3-bit opcode selection because there are eight operation, and we use Verilog design to code this project.
Okay, for block diagram, the inputs A and B enter the loop. The operations are available which are XOR and NOT, addition, shift right, decrement, or and subtraction. We assign operation codes for the 8 operations, where the multiplexer will select the operation that will be generated. The output results are generated, zero flag and carry flag updated automatically. For input and output description, there are three inputs and three output, where A is input, signal B is input, operation code is input, results are output, zero flag output, and carry flag is output. For operation code table, we use a 3-bit opcode for declare the operation, where 000 is XOR, 001 is AND, 1010 is NOT, 011 add, 100 shift, 101 decrement, 110 or 111 subtract.
This is our Verilog coding. First, design module. Module CPU 16, then input A, input B, input opcode. Next, output register, result, output register 0 flag, output register carry flag. Then register 160 temp, always begin, carry flag equals to 0. Next, case opcode. For XOR 000, for opcode for AND 001, and for NOT opcode 010. Next, for addition 011. Next, shift right 100. For decrement 101. For OR 110. For subtraction 111. Then end case, if result equals to 0, the 0 flag equals to 1, else 0 flag equals to 0. Then end module. Next, test bench. In the test bench, we use this output, input and output to get the results.
These are the results we got from our coding. For the first operation was for ZOR. So our for ZOR, the input was 000F and 005. The output we got 000A. So which indicates 0 flag is 0 and there's no carry also. Then the second operation was N. The first input 00F and the second input 005, and the output was 0005. They also know 0 flag and carry. For the NOT operation, we use the A input, the first input, 000F, and when we NOT it, we got FFF0. Also, there's no 0 flag and carry. For the addition, FFF and 0001, which result in 0000, which means there's a carry and there's a 0 flag. And for the fifth operation, which is shift right, we use the first input 0008, and when we shift right it, we got the output as 0004. And also, there's no carry flag and 0 flag. And for the sixth operation decrement, we use the first input 0001, and as output we got 0000, and there is one then there is 0 flag and no carry. For the operations For the seventh operation, which is OR, the first input 000 F and the second input was 0005. The output was 000F. There's no zero flag and carry flag. And the last operation was subtraction. First input was 000A, the second input was 0005, and we got a result as 0005. And also there's no zero flag and carry flag.
Good day, sir and ma'am. So this is our result waveform. So as we see in the waveform we get for the input of 111 and 0101, for the XOR output we'll get for 1010, and for opcode 001 we'll be using AND. So for the AND, the same we will get for the value of 0101, and then for 010 for the opcode of NOR we use only operand A. So the value of A will be only changed. So the 4 bit on the back will be changed into 0, and the others will be changed to 1. Okay, so this is for our addition. We have used for output of 011. So for this, for all the bit we in the input A we use for 1, and then for the B we use the LSB only 1. So when you plus all this, the value become the every value becomes 0, and then the 17 bit will have the value of 1. So the 17 bit will become the carry flag, and then since all the output value is 0, so it will become 0 flag. And so for the next one is shift right. So in this we use in the input A, the value of 1 will be stored in the fourth bit. So the fourth bit will move to right. If you see in the output, it will be shifted to right. And then next one is decrement. So if you see, we're using the opcode of 101 for decrement. So if you see, means the value in the input will have one at the end. So the one will be decremented to 0, and since all the input output value is 0, so it will become the zero flag carry will be zero flag will be equals to 1, but then the carry flag won't be affected. Okay, so this is for the 110, where the the operation for this is for OR. So if we use the input of 11 and 0101, the final value will be this, since even if one input is present for all the output will become 1. And then so for this one, the 111 will be used for sub. So when you use the 1010 to sub with 10101, so we will get this value of 0101. That's it from me. Thank you.